Hello, everybody. This is Jason Nadeau with Dremio, and I just want to do a quick introduction and welcome to our webinar today. We're going to talk about the top 5 data industry predictions for 2020 and help you see what you should expect. So we just kicked off the top of the hour. We're going to give folks a couple minutes just to get connected and pardon that little technical difficulty there. Give folks a couple minutes to get connected, and then we'll get going. So while we wait, we'll get some nice little elevator music happening in the background, and even show people a couple quiz questions to kind of keep you entertained and informed while we wait to get started. Bet you didn't know how big an narwhal got. So that's question 1. Yeah, we've got one more question here. Let's check it out. A little pre-webinar quiz. This really is fascinating. I think about, like, what the heck is the narwhal, tusk, right? It does turn out it's a giant tooth. That's pretty amazing. Biology is something. Why? The question I always ask my daughter asked me is, why don't more things have those big, giant horns, right? Why only the narwhal? All right, so I think we've given a couple minutes. Folks should all be connected. Welcome, thank you for joining us today. We're gonna have a reasonably brief webinar. I think we can get you out of here in less than 30 minutes. And we're gonna talk about top 5 data industry predictions for 2020 and what you should expect. And I'm the speaker. My name is Jason Nadeau. I'm the VP of Strategy here at Dremio, and but before we kind of dive straight into the predictions themselves, I'm just going to run through just a little bit about what the problem is that Dremio is solving in the marketplace, just to provide some additional context, and I think you'll see some of the connection to some of the predictions that we're making as well, given the challenges that we generally see in the marketplace. So as we go, of course, we want you to absolutely ask questions along the way, and we'll absolutely do our best to get through them all in the course of the webinar. If we don't manage to get through them all, we'll follow up for sure individually afterwards. So the way to ask questions is to use the Zoom control panel, and the very best way is to click the Q&A button that you see over there on the lower right. I think there is such a thing as chat, but the chat doesn't record the questions very well, and makes it more difficult for us to answer them. So please, if you have a question, that's great. Use the Q&A feature, and then we can much more easily kind of run down them. So with that, let's kind of get into it. And as I mentioned, let's just start talking a bit of context setting about what's happening in the data and analytics world. And really the big thing that we see as, not just us, but just the situation that exists with analytics is that this whole stack is a legacy stack that's been around for a long time, in decades really, and it's built on a bunch of different workarounds, 3 big ones, in particular. And so the first is, people have been centralizing all of their data in an expensive and proprietary data warehouse-based architecture. And you go through a lot of effort to move data into that data warehouse or data warehouses, and it doesn't matter whether those data warehouses are on-prem or in the cloud, right? The architecture is still the same. You've got to go through all this brittle and complex ETL or ELT to massage that data, get that in there. And once it's in, it's proprietary, and you're constrained in terms of how you use it. But what's frankly more interesting from an analytics point of view, and more problematic, is that by and large, the data is still not performant enough to actually work with in a truly interactive way. And so then there's this whole other set of workarounds built on top of data warehouses, cubes, BI extracts, aggregation tables, basically a set of acceleration workarounds to try to make the data fast enough to actually be consumable by the different consumers that actually want to access it. So data scientists with their different tool sets, and business intelligence users as well. And so these different workarounds exist to make the data fast, but as you see, looking at this kind of gray pyramid slash triangle that's going up in the background here, as you move up this analytic stack, you're working with less and less data. And so the cubes that are being created, or these extracts and whatnot, they're very narrow slices of data. And while they do provide the performance that those end users are demanding, so often, as I'm sure you all experience, you want to do something else with the data, and you need additional data, and that means you need to go back through and get a whole another project and a bunch of time passing to redo the cubes, add in, join other data, and so on and so forth. So lots of restricted capability and time. It's a real pain. And it's painful for everybody in the stack, right? If you're a data consumer, like an analyst or a data scientist, you're spending all this time waiting to get your data. It's difficult to find it. The amount of analysis you can do is severely constrained because you don't have as much data. And if you're the people helping to build that infrastructure, it is a challenge every day, right? People can just get buried building these cubes and extracts. Hard to spend time modernizing the data architecture and really making it built for the cloud, fast and open. And of course, there's all these copies that are floating around now too, which is difficult to govern. So copies of data, all these cubes, extracts, everybody's got their own. They proliferate like crazy, and it's really becomes a wild, wild west. So that's the sort of the world. What if we could eliminate the workarounds with a whole new architecture that's just built differently? And that's what Dremio is doing. And so we call what we're building a data lake engine. It is really a whole new architecture on top of an open data lake storage environment that's purpose-built for truly interactive analytics. So here you can see, hey, it's a much simpler picture. We've got our data lake storage. For most people, that's going to be in the cloud with AWS S3 or Microsoft's ADLS. Can be on-prem still too with Hadoop, for example, but we see a lot of modernization towards cloud data lake storage. And our data lake engine sits on top of that and makes that data available to all these different users and consumers. So what is Dremio really? It's an accelerated, highly accelerated to make things actually work at truly interactive speeds. It's a data lake query engine with a rich semantic layer. That semantic layer helps people to find, share, interact with, and govern their data. And so last slide on what Dremio is doing here, but really we're helping people like you to unleash your data lake. And only Dremio is delivering an instant interactive response, right? So like truly, sub-second and, in many or even most cases for the types of data that people are looking at, highly efficient compute. So it's not just one thing, to have, compute in the environment, particularly if it's in the public cloud. You want it to be efficient. You want it to cost as little as possible because cloud costs, they're getting up there. And we deliver governed self-service. So we make it easy for all these end users and consumers to find their data in a governed way so that the right people see the right types of data. We have control, we have lineage, we have all sorts of things. And then you can see the result, right? We're eliminating cubes, eliminating extracts, eliminating, frankly, the whole category of data warehouses. Kind of an interesting thing. We don't need that anymore in this new world. And the outcomes that our customers are seeing are pretty dramatic. So 100 times faster time to insight, right? From the time you want to start doing something till the time you can actually do that analysis. And since you're not waiting that 100x, you're doing more analysis. Then you see the 10x more efficient. So all of our compute is very, very fast, and that makes it also very, very efficient as well. So that once those those instances in the cloud, for example, are spun up, they don't run for very long. They don't need to because the work is getting done so much faster. And that's altogether a much more simpler and open environment, infinitely. So a little bit of perhaps a stretch there, but it really is a dramatic difference, and you can see it in the picture of the architecture itself, just how much simpler it is. So that's Dremio. That's kind of the broader environment that that we're working in, and we're big believers in data lakes and how the data lake can really transform the environment for analytics. So, given all that, let's start making some predictions here. So, prediction number one: cloud data warehouses turn out to be a big data detour. You can start to see why this would be, once you kind of think about that architectural shift that we just showed. So there are many people who have on-prem proprietary enterprise data warehouses, right? These have been around for many, many years. Teradata, Netezza, and many others. And of course, those appliance-based hardware, solutions, they tightly coupled compute and storage together, and that made them pretty darn expensive to scale, also, right? So that was a real challenge, in general with these on-prem data warehouses. And so what has happened? Well, we started to see some additional market entrants with better data warehouse implementations that are running in a cloud-native way. And while that's a great thing, and those new architectures will allow for independent scaling of storage and compute within the structure of a data warehouse, and that's a good thing. They're still data warehouses, and they're still proprietary, and the data that enterprises have is still locked into those data warehouses. They're still quite expensive. They're definitely better than the original generation of on-prem data warehouses, but they're still data warehouses. And so what we're seeing is savvy enterprises are realizing they can avoid the entire cloud data warehouse detour and just go straight to a modern open cloud data lake environment. And that's a big architectural shift, and it is really creating a ton of value for enterprises, because now they're getting true separation of compute and storage. So in a cloud data lake world, the data is absolutely kept separate. It's in the data lake storage environment, in S3 if you're in AWS, right? In ADLS if you're in Microsoft, and that's your data. And then as an enterprise, you get to bring all sorts of different best of breed processing engines and tools and technologies to take advantage of that data, to explore it, to analyze it, and you're not locked in. And that kind of freedom is really, really powerful. And we're seeing savvy enterprises move to this quickly. And so, on this slide, not only do we predict that data warehouses turn out to be a big data detour, and enterprises just ultimately skip over them or use them as a temporary placeholder, we predict that 75% of the Global 2000 will have a cloud data lake in production or in pilot in 2020. So that's prediction number one. Prediction number two: enterprises move from raw performance to price performance. This is really interesting. And what's the driver? The driver is the cost of the cloud. The cloud is not cheap, and but we also know that people are moving to it, very, very quickly. Enterprises, just about everybody's got a cloud modernization program in place, and 84% of users are realizing that, wow, the cost of moving to the cloud can get pretty large, and so they're looking to implement some sort of cost controls. Now, at the same time, the cloud is providing a whole new set of elastic capabilities. And by elastic, I mean things can spin up, but they can also spin down. And that's a really, really powerful capability that on-premise environments just don't have. In the on-prem world, you buy your, you size and you deploy your infrastructure, and you typically have to do so to support peak loads. And then you've got an underutilization problem, an over provisioning problem is a way to think of that. So the infrastructure is kind of relatively fixed, and in that world, it can be very difficult to reclaim any of that under or sort of free space, if you will, free utilization. And so the focus has been, hey, let's focus on performance, better performance. So let's compare solution A versus solution B. Whichever one's faster, especially for things that are performance intensive, and analytics definitely fits in that category, faster wins. But once we go to the cloud, the whole equation changes. And the elastic nature of the cloud allows us to say, hey, not only can we throw compute at something and make it fast, well, that compute costs more. So my costs start to scale with my performance. And so then the question becomes, well, how do costs scale with performance? And that is the price performance curve. And so in this new world, we can see that, and we're seeing this all the time, is that the better solution is the one that delivers performance at a lower cost. So if you look at this curve here, you can see, follow the solution B line, where for the tip of that solution B arrow, in other words, that sort of on this curve anyway, at that point of performance, it can deliver that same performance at a much lower cost than solution A, right? So it's a lower curve. It's delivering performance at a lower cost everywhere along the curve, and that is super exciting. So if you're an enterprise, that's what you want to be looking at, not just absolute raw performance, but what the price performance curves look like and how different solutions scale their performance along with cost. It's really interesting. We think in many cases, performance can almost be arbitrary. Like you can kind of get as much performance as you want. The question is at what cost? And so that's why we predict that enterprises in 2020 are going to move from looking at raw performance to price performance, especially driven or particularly driven by their adoption of cloud-based solutions. So prediction number 3. IoT data finally becomes queryable. So IoT data is exploding, and that's part of the big challenge. There's just so much data. Gartner predicts that by 2025, we'll have 25 billion connected IoT devices. I think coming out of 2019, the number there is maybe closer to 19 or 20 billion. It's still growing fast, but that is an unbelievably large number. And all of these devices are generating about 500 zettabytes per year already, and that's growing exponentially according to Cisco. And so first of all, the question is, how big is a zettabyte? How many people have even heard of a zettabyte? So zettabyte's a lot of data. So you think about petabytes. People might know what petabytes are. Probably know what petabytes are. 1,000 petabytes is an exabyte. And 1,000 exabytes is a zettabyte. So 500 zettabytes is a lot of data. Now, here's a question for people. Of course, you probably have Google. You can go find this out. But you may wonder, what comes after a zettabyte? And it turns out the answer to that is a yottabyte. And so 1,000 zettabytes is a yottabyte. And sounds a little bit like Yoda. So we wonder what comes after yottabyte? Is it a Vaderbyte? We don't know. It's not defined. I guess it'll probably be a little while before we have enough data to figure we need a new term. But zettabytes are a lot of data, and so that's really difficult to query. But that data is landing into data lake storage environments. Generally speaking, that's like the best home for this type of data, semi-structured data. It's certainly not going into data warehouses. So the data is there, but the volume of it, the variety of it, is really challenging to process and query. And so we're excited to see that our partners over at Software AG have built a purpose-built solution for IoT data and analyzing IoT data. And they call it the Cumulosity IoT Data Hub. And so with this solution, we're like super excited to see what organizations of all different sizes that have IoT data are going to be able to do with that data, because now for the first time, it really is queryable. It can be explored interactively. You can join that IoT data with other operational data that you have, and really get some powerful insights and ideas, which is why you see the light bulb over there on the right-hand side. So data scientists building fancier models, better predictive power, business intelligence folks wanting to augment their reports and their dashboards and just do ad hoc exploration as well. Machine learning, all sorts of really amazing stuff is now going to finally become possible in human timescales, right? Like an actual almost real time as well. Really interactively queryable. So we're excited about that one. Fourth prediction: the rise of data microservices for bulk analytics. So, like, what's a microservice? Like, what we've seen is, in general, this really interesting trend in IT architecture where folks are moving from monolithic stacks to distributed stacks, and microservices really take that kind of all the way, right? Really kind of disaggregate, if you will, the different components of an application into a bunch of very small components called microservices, and these things are all interacting and kind of working together to deliver the functionality that we need. But the trouble is that the transports that allow the communications to occur between these different microservices are fundamentally slow and serialized. Like, it is difficult to move data between microservices and the operational data stores, that those microservice compute farms are pulling data from. And so, like, in practical terms, people can pull in, or a microservice can pull in, like, on the order of thousands of records at a time. That's not a lot of data, when you think about the types of analytics that the data scientists in particular want to get their hands on and analyze. And so, the end result of that is, the architectures still tend to stay fairly monolithic and tightly coupled. And that's a problem, because when architectures are tightly coupled, they're slow to evolve. Like, the benefit of microservices is, like, the individual piece parts can update, can evolve, and the whole environment can innovate much more quickly, and that just delivers a lot more value for everybody. And so, the slow communications is a real problem. But here's the good news. Arrow Flight is another Apache project. Turns out Dremio's behind this, not too surprisingly. We're not the only one. We co-created it. Arrow Flight is really cracking open the communications path between these microservices and the rest of the environment. And so Arrow Flight is going to allow for billions of records in a massively parallel new architecture, so that ultimately we can move to very loosely coupled architectures that are fast to evolve. So we think the term we're coining here is this move from operational microservices, right? Small amounts of data, very operational focused, kind of the transactional stuff, that exists, typically in your database or perhaps data warehouse, to data microservices with this ability to pull in really bulk data operations, like large amounts of data, and have that be worked with kind of in near real time. So that's going to just unlock a ton of innovation, these loosely coupled architectures that are fast to evolve. So we're really excited for the potential of Arrow Flight to unlock this for all of us. And we think this is going to be a big thing in 2020. And our last prediction. So Apache Arrow becomes the fastest project to reach 10 million monthly downloads. So if you've been following data science, you'll have definitely heard of Apache Arrow, another Apache project that Dremio co-created. And really, this is about columnar in-memory data processing and sharing. And analytics type data is all about columnar type formats. And Arrow really made this something that could be used by many different projects, and is already powering dozens of open source and commercial technologies, including obviously Dremio as well, but Spark, and you see the list here, Python, Dask, and so on, TensorFlow, across many different programming languages. So the adoption and the downloads are really spectacular. And so you can see we're already over 6 million, or I should say Apache Arrow is already over 6 million downloads. We're predicting that kind of middle of 2020, we're going to cross the 10 million mark. That'll be about 4 years from the time that it was introduced. And that's just super fast. You think about some of the other data science projects, big popular ones that are out there. So Pandas, currently at 17 million downloads a month, but it took them about 5 years, to get to that point, is our estimation. Some other, projects you've probably heard of, TensorFlow, 5 million downloads a month. So I haven't even, crossed the 10 million line. Jupyter, PySpark, still very popular, lots of downloads, but it's really great to see Apache Arrow take off so much, because this ability to have data sharing, in memory, fully columnar, a much better representation, just adds so much more performance to all these different applications and technologies, including Dremio, so that everything just works together. And we avoid all the serialization and deserialization that would have typically had to occur, the extra copies, the overhead, and so on, just making everything about 100 times to even 1,000 times faster. So that's our predictions. And now we've got a little bit of a bonus here for folks too. We've been doing some primary research, and I just wanted to share just a couple preview kind of survey questions that also kind of give you a sense of what's happening out there in the world of the data lakes and the challenges that are out there. So we surveyed over 1,100 people across a bunch of different industries. You can see here, finance, healthcare, really kind of popped off or popped up, on that list there. And most of the organizations we surveyed were, over 1,000 employees, but a pretty good mix. And so when we think about when we asked folks what they consider the benefits of a data lake to be, a couple things kind of pop out here. So you can see over there on the right, yeah, the data lake's being used as a complement to data warehouses. And that's no surprise, right? Because people have data warehouses, they're looking to modernize, offload things from those data warehouses. And so data lakes become a useful way to do that. But what's more interesting is the data lakes themselves being used for advanced analytics and data exploration. And that's really what excites us, and really what we see customers doing as well. And as I mentioned earlier, don't need a data warehouse to do that. They can just use us directly on a data lake. And then in terms of challenges, these are also not a surprise given that sort of original architecture and what people are trying to do as they begin to move over to it. And data discovery, there's a lot of data that's out there in that data lake. Helping people to find that data becomes really important. Data cleansing, again, lots of different variety of data coming in, and it does need to be cleaned up. Like you can't avoid that, whether it's data warehouse or data lake. So that will be a sort of an ongoing challenge, is kind of part and parcel with data. But the data access is another one, right? Like if you're a data consumer and you know that there's data in the data lake that you want, getting actual access to it is a real challenge and takes a lot of time. The IT needs to get involved. Data engineering teams need to build that stuff, and that slows people down, right? And that's a bunch of the challenges we talked about earlier. And so here's a bit of a double click on that. So if you depend on IT to access your data, how long do you have to wait? And looking at this, the quick math on it is for 70% of respondents, it takes more than a day or more to get access to their data. And for 43%, it takes a week or more. And we routinely see people, telling us it takes multiple weeks, to get access to the data that they need for their analysis. And then in today's world, hyper-competitive economy, that's just way too long. And so people need more. And frankly, if you're on the other side, if you're in IT and you're having to do all that work, getting buried by all those all those requests to build data pipelines and potentially more cubes and various other things, that's not a lot of fun either. And really, those folks want to be spending their time on strategic activities, moving to modernize the data infrastructure. So that brings us to a close. And I just wanted to say that was a quick survey, or a quick preview, I should say, of a pretty rich survey that we put together. And we'll be sharing the details of that in an upcoming webinar. So definitely stay tuned for that one. Can't wait to share with everybody the full set of the research there. So with that, a couple closing words, and we'll take some Q&A. If you want to go try Dremio, go do it today, right? You can run Dremio and deploy it into whether you want to do it in the cloud of your choice or you want to run it on-prem. You can go grab the software and start playing with it today. The community edition is free. We also have a Dremio University, which is where you can go and really learn all about how Dremio works, how to use it. It's really quite a rich place to go learn. And as well, once you've actually got up and running, there's a whole community there for you to learn from, share best practices, and ask questions and so on. It's a great, vibrant community, and so these resources are there for you. Okay, so with that, we will. That's the end of the prepared remarks and whatnot. Let's go to some Q&A. So first question that we see, again, using the Q&A tab. Does Dremio do anything to help people to migrate from an enterprise data warehouse to a cloud data lake? Absolutely, we do. And this is not from a professional services point of view, though we do have services as an organization, but the semantic layer that Dremio has, which allows for data, essentially a virtualization of physical data sets, and virtual data sets that the virtual data sets are what actual end consumers are connecting to, and the physical data sets could be in the enterprise data warehouse and then in the data lake. And so that semantic layer allows for organizations and enterprises to modernize under the covers, move their data from on-prem to the cloud, change where the physical data sets are, and still keep the virtual data sets and the connections between those virtual data sets and end consumers, BI users, data scientists, and so on, intact. So the move becomes much more transparent and easy to do, and enterprises can do it at their own pace. So absolutely, we can help. It's a big part of, frankly, of one of the main reasons why people buy, and use Dremio. They want to accelerate their analytics, but they also want to modernize their data infrastructure. Okay, next question. Let's see. For anybody who wants to know if they can get a copy of the video of the webinar, we will be posting the webinar. And so absolutely, you'll be able to go and grab access or grab that as well. Another question here, is it possible to know a reference of pricing? So the community edition is absolutely free. You can go and use that today. But once you've played with that and kind of get a sense for what the capabilities are, the best thing to do is to reach out, get a demo, and see what the enterprise features are going to look like, and see what that looks like, and then talk to our sales team. So we don't just give out pricing directly. So definitely give a reach out to our sales teams. They'll help you to kind of walk you through. Here's another question. Is Arrow Flight helping to separate compute and storage? Yes, I think I touched on that a little bit earlier. So the monolithic architectures obviously keep things together, and that's just kind of like what you have to do. But once you can actually start having this disaggregated approach, and Arrow Flight is absolutely helping to do that, we can start to say, okay, well, let's put storage here, let's put compute there. We can still move data quickly, and that creates this real separation. And we're big believers in true separation of compute and storage. Is why we built our data lake engine to sit on top of data lake storage. So it's bring your own storage with Dremio, right? There's no lock-in with us like there is with a proprietary data warehouse. So we're big fans of separating compute and storage, and Arrow helps with that. Arrow Flight absolutely helps with that as well, and it's one of the big reasons why we're behind those Apache projects. Okay, so another question, maybe I think this is the last question we have, and then I think we're done. And that question is, how does Dremio give access to data unlike a data lake? So if I understand the question, the data lake's not the only source of data that you're going to have in your environment, for sure. And so Dremio connects to and is optimized for accelerating queries on data lakes, but has connectors into a number of other data sources as well. And so that's really important. It's important so that you can, join, maybe it's, some other operational databases that you've got, whether they're, traditionally, relational, or others, MongoDB, for example, NoSQL databases. So Dremio can absolutely reach in and talk to those databases and do joins. We've got a bunch of advanced relational pushdowns capabilities, for example, to make sure that that's fast. And the other thing that, of course, having that ability to talk to multiple different data sources is useful for is doing that data modernization. So, we can help connect your end users and your data scientists and whatnot to data that's currently in, for example, a data warehouse, could be an on-prem data warehouse, could be a cloud data warehouse, and then help facilitate that migration, over time as that data gets moved into the data lake. So I do want to be clear, there's a difference between data virtualization and what Dremio is doing. We're not data virtualization. There are other virtualization solutions, if that's really what you want to look at, federation. Really the difference being that virtualization is about a sort of an end state, if you will, of having lots of distributed stuff. And we don't think that's the right architecture. We think the right architecture gets to really put the vast majority of the data into the data lake. There's lots of different distributed sources within it, of course, but that's where most of the data should be, because it's just a fantastic repository. It's inexpensive, it's highly durable, it's very open, and it's very elastic, you know, and it can handle these huge volumes. And so, you know, really people should be, you know, modernizing towards a cloud data lake centric approach. But of course, you're still going to have other sources around it, and Dremio will help connect to those as needed. And that takes us to the end. So I want to say thank you to everybody who attended. And if you have you know, other questions, you can definitely, you know, get us through social, get us you know, online. And we hope you all have a great rest of your week. And thanks for your interest in you know, in Dremio. We look forward to working with you in the future.